Grade 11s and welcome back. So question 10 says, in the diagram BE and CD are diameters of a circle having M as a center. Chord AE is drawn to cut CD at F. AE is perpendicular to CD and let angle C equals to X. That is angle X. Now the first question says, give a reason why AF equals to FE, right? So due to space constraint, I'll just highlight this question with the same color that I'm going to use to give a solution for that question number or that question. So 10.1, the reason why AF equals to FE is because CD bisects AE. Why? Because AE is perpendicular to CD. So CD is a perpendicular bisector. So it bisects AE. So it cuts AE into two equal halves. Hence, AF equals to FE. Right. 10.2. 10.2 says determine, given reasons, the size of angle M in terms of X. And now we can see angle M1 there, sorry, angle M1, I said angle M, so that is angle M1, and then that is X. So we need to give the size of angle M1 in terms of X. So what we are going to do here is to establish the angle that we can use to determine angle M1, which is related to angle X. So 10.2, our starting point here is that if you check arc CE, it subtends angle M1 at center, right? And the same CE subtends angle A1 at the circumference of that circle. So we know that angle at center equals to twice the angle at circumference. And angle A1 is somehow or can be related to angle X or rather X, right? So our starting point is angle A1 equals to 90 degrees minus X. And the reason is angles of a triangle. We know that angles of triangle sum up to 180 degrees, but we already know that this angle here is 90 degrees. So we already taken out that angle. Now it means angle A1 and angle X is equals to 90 degrees. But then angle A1 equals to 90 degrees minus X. Hence we say angle A1 equals to 90 degrees minus X. Therefore, but angle A1 or rather angle M1 equals to twice angle A1, right? Reason angle at center equals to 2 times angle at circumference. Angle at center equals twice angle circumference. Therefore, angle M1 equals to 180 degrees minus 2x. So just multiply everything by 2 from angle A1 because angle M1 is twice angle A1, right? Now we're going to the third and the last question in this question that we're going to solve. It says prove given reasons that AD is a tangent to the circle passing through AC and F. So there is an invisible circle that passes through point A, point C, and point F. Now you need to determine that this AD is tangent to that circle, right? 10.3. So there are many ways to kill a cat, but I'm going to show you my way. So if you look at this whole angle A here equals to 90 degrees, right? because it's angle in a semicircle, right? So we know that CD is a diameter. So the angle that is subtended by a diameter, we know is equals to 90 degrees. We know that angle is angle in a semicircle. So we know that angle A1 plus angle A2 equals to 90 degrees, right? Then we know it's angle in semicircle, right? But we know that angle A1 equals to 90 degrees minus x, right? Therefore, when we substitute angle A1 here, which is 90 degrees minus x plus angle A2, this is going to give us 90 degrees, which is this one. So we just replace A1 with 90 minus x. But if you take everything from this side to the other side, which is what we do normally, so we're going to left with angle A2 this side equals to, when you take this 90 degrees, going to be 90 degrees on the other side minus this 90 degrees plus x, because x is going to the other side, so it's going to be plus x. Then we know that 90 minus 90 equals to 0. Therefore, angle A2 equals to x. So if angle A2 equals to x, therefore AD is a tangent at A. Why? Because if this angle equals to x, therefore this angle equals to that one, therefore this is a tangent, then this is tan chord theorem. So this angle, the angle between the tangent and the chord at the point of contact equals the angle in the alternate segment. So therefore we've proven that indeed AD is a tangent to a circle passing through point A, C, and F. So